So recently I was invited to contribute to writing a review paper with some colleagues of mine with the aim of trying to identify what natural product research had been undertaken in the past in this country. And then to look at what were some of the gaps maybe that resulted from that research so far, missed opportunities, limitations, and also the strengths. So the title probably gives it away that we've really identified that the arid zone is a virtually or relatively untapped region for researching plants for the purpose of discovering novel bioactive compounds. So I'm going to start sort of looking at a bit of the history and walking our way through to give relevance to South Australian flora and where our team believes South Australia plays a real important role in the future of bioactive compound discovery. So it's my view that natural product research in Australia started a very long time ago when Australia's first peoples started migrating to this country. So it was sort of over 40,000 years ago. And then a long period before the first fleet arrived in 1788. So a huge, rich resource of knowledge, both ecological, medicinal, etc., has been developed over that period of time. But it was in 1788 when the first fleet landed that the Surgeon General, Dr. John White, at the time first distilled the essential oil from eucalyptus. And it was at this particular point in time that essential oils were sort of the real buzz area of identification and research and trying to extract out of different plants. But it was not until a few decades later after this first distillation where there was actually first industrial production on a larger scale of these oils. And then in the early 1900s, the germicidal properties of Melaleuca alternifolia were first published. And again, essential oil research was still a hot area. But then it started to die down and shifted more towards trying to identify sort of single bioactive chemical constituents out of various plants. And then in more contemporary times, there was some larger natural product research programs undertaken. And the first of these was for around about a period of 30 years by the Council for Scientific Industrial Research, which is now CSIRO. And this became known as the Australian Phytochemical Survey. That sort of died down around 1970, and then in the early getting to the late 90s and into the early 2000s, a massive undertaking between Griffith University and AstraZeneca, sort of magnate pharmaceutical company, undertook this biodiscovery collaboration. And I'm just going to go into a little bit more detail into these two because they're really the two sort of standouts of past natural product research, and there are a few things that we can take away from that and learn. And the question mark is, what is beyond this? So the Australian Phytochemical Survey really started off as a complementary product to existing natural resource mapping being undertaken. There was really a random collection strategy that was implemented to identify plants to screen, with a particular emphasis on the alkaloid class of secondary compounds, because at the time alkaloids were seen as the most sort of physiologically active compounds, so everyone was interested in trying to isolate and identify these, with the view that these compounds might have application in human, veterinary or agricultural areas. As time went by, the initial sort of start of the project sort of outgrew the capacity, and so invitations were sent out for collaborations to be set up with other universities and other chemists to contribute towards the project. And with that, an expansion of different regions from where the flora were being collected. So a massive scientific sort of input from this work, with over 4,500 different species being collected and sort of identified, and nearly 2,000 scientific articles published as a result of it. Funnily enough, as much as the chemists were important in this particular program of research, they in some ways contributed to the demise of the project because they became less interested in the biological application of these compounds and more so in just simple chemical studies of it. So that was interesting. Then more recently, a massive sort of research collaboration between Griffith Uni and AstraZeneca, a financial investment of what's been reported as over $100 million. Now, very little of this has actually contributed towards conservation of biodiversity, which is one of the arguments around doing this sort of work in the face of conservation, where actually not much actually goes back to it. And this is as a result of various contractual agreements. And in this particular case, there's not a lot of clarity around that aspect of this work. So we can't really learn a whole lot from it. And they, again, like the Phytochemical Survey, they did contribute a lot in the way of scientific knowledge and identification of new species. Unfortunately, it has been, or the team has been criticised for the way in which they collected the different flora, with some suggesting there was infringement of trespassing on Indigenous owned land without prior consent. But I won't go into that any further. So some general conclusions about all this previous work. It really appears the major emphasis were on non-arid environments, so typically tropical, particularly in the Queensland areas, and sort of temperate zones. A question around the strategy towards collecting these different species for the discovery of compounds. A massive scientific contribution, nonetheless. But the funny thing is, with all this application towards use for humans or veterinary or agriculture, we really see little commercial application actually coming out of all this research. And there's possibly a number of reasons for why that is. And I think one of the key things, which is really close to my heart, is the limited involvement of Indigenous communities within this research. So the question is, well, where to now? I really like some of the other slides showing the maps of Australia and to identify the arid zone regions. This one's from the Bureau of Meteorology, but it clearly still indicates that we have a large land mass which is predominantly semi-arid to arid, about 70%. And much of the previous natural product research has focused on the minor part of the continent. So there's a real opportunity here to look at arid zones for the discovery of novel compounds. Now, this is not to say that no arid plants have ever been investigated. Of course they have, but they've been minor relative to other research. So why arid zones? Well, they provide a different in terms of that plant they're exposed to, and I don't need to tell this audience or go into too much detail, probably know more than what I do. But this, of course, can then relate to the production of different secondary metabolites within these plants that may play a part in the plant's survival and therefore have some form of biological activity. Some of the more important abiotic stresses include desiccation and large temperature differentials, poor soil, or nutrient deficient soils, i.e. low nitrogen, high salinity, and a lot of sort of oxidative processes going on within leaves and that. So that has to give rise to some sort of defence mechanism and possibly through production of secondary compounds. And that's just to touch on sort of Heberian biotic stresses, such as fungal pathogens. Arid zone plants do suffer from fungal pathogens, and an example is Nicodiana, and there was some research done in Utah a few years ago which showed the Nicodiana, one of the species of Nicodiana, with a massive fungal outbreak. And so these types of observations and sort of ecological interactions then could be giving rise to plants to produce, producing compounds that may be of biological interest for us. So quickly, just to look at some common strategies that are generally used in this area, too much detail, using Indigenous knowledge, chemotaxonomic, ecological and in silico. And if we look at the past research, at least in this country, the ecological approach is really lacking. and yet it can be such a real important strategy if used right. But unfortunately, a lot of funding bodies don't necessarily have the money to pay us to go out and observe the environment for periods of time. But luckily enough, we've got people who have that knowledge already that we can tap into, and this is, of course, Aboriginal people. And as we saw yesterday with the Welcome to Country by Carl and his nephew and sister, they really want to be involved in working with researchers, and I think that's a really great thing. So if we can combine Indigenous knowledge with Western ecology and Western science all together, we can create a really strong strategy to hone in on these plants that possess biologically active compounds. So the opportunity for South Australia, it's a relatively untapped area or region for bioactive compound discovery with a massive area that's predominantly arid, and I really want to thank Andrew Lowe and his colleagues who have recently published the paper on the board there, identifying centres of plant biodiversity in South Australia, because this gives us a real sort of head start as well to combine in not only the Indigenous ecological knowledge and the knowledge we already have, but to sort of go to these centres because there is species richness there and the diversity that we're after. In this state, we have all the relevant in-house experience to make this research happen, so right here in South Australia. And we can use the ecology of our unique SA flora combined with Indigenous eco knowledge to make this happen. And also think here that we have really strong state government agencies, and in particular the State Herbarium. We saw over 1 million sort of samples there across whole different taxa available, and that knowledge is here to tap into. And we might even, in doing such work, come across similar novel compounds like these, which are from Aeromophila cerulata, which are unique novel cerullatane diterpenoids. So just so happens that we have the Australian Bioactive Compound Centre, which you can hear more about in 2 talks' time from Casey Hall. She will go into a little bit more detail about what the centre is about, which I believe can facilitate this work into the future. And so to conclude, in keeping with the theme of this symposium, I thought I might put out my prediction for the future of botany, at least in this state, and it is one which lies in South Australia. It will consist of a coordinated transdisciplinary team of experts passionate about nature, exploring a virtually untapped paradise of bioactive arid zone flora. Thank you.
Thank you, Bradley. Any questions?
Yep.
For this compound discovery, how much of a plant do you typically need to collect?
In the first instance, we might randomly collect from, say, 10 plants, but we generally don't need a lot of material.
Whole plants?
Whole plants. We might collect leaves, stems, roots. At one time, a kilo of material is probably sufficient. But we saw earlier this morning with Buer's talk, and we actually can just go about identifying the compounds and then sort of leave it at that and use these newer technologies to upscale production, which I think is a fantastic way to go.
Anyone else?